Hello friends, I'm Dr. Rajesh and I am with you with my next video lecture. And in this lecture we will be discussing this particular problem. If a group has 4 elements, show that it must be abelian. So let us suppose that let G be a group having 4 elements. Identities must in the group and other 3 elements are A, B, C. Required to prove G is abelian. Since G is a group, G is a group, then every element of G has inverse in it. मतलब कि इसके हर एक एलिमेंट का इसके अंदर इन्वर्स जरूर मिलेगा. फॉर एन एग्जांपल वी नो दैट E inverse is E itself. Okay, rest we have 3 elements. Inverse of any of the one element, इनमें से किसी 3 एलिमेंट्स में से इसका इन्वर्स ये हो सकता है, इसका इन्वर्स ये हो सकता है. एक एलिमेंट जरूर बचेगा जो अकेला होगा और वो क्या होगा, खुद का इन्वर्स होगा. E inverse A inverse, let us say that element is A inverse is equal to A, because पेयरिंग 2 की हो सकती है. इसमें आप यहाँ देखिए C inverse could be B, B inverse could be C, so A will be the element whose inverse will be A itself. So other B inverse could be B, C inverse could be B. So this is the probability that A inverse will be A. So this is you could use here. Then now here 2 cases arises. Case number 1, if B inverse is self inverse and C inverse is self inverse. In this case we have E inverse is equal to E. Okay, A inverse is equal to A, B inverse is equal to B, C inverse is equal to C, implies every element of G has, then by the last theorem we have studied that if every element of G has inverse, this implies that G is abelian. So for that particular case G will be abelian. Now I am again discussing that here we were having 4 elements. E inverse is identity itself. So out of these the one possibility is that's possible, one C inverse is B, B inverse is C. So यहाँ एक एलिमेंट तो कम से कम बचेगा, वो हमने लिख लिया A. उसके बाद ये भी पॉसिबिलिटी है, केस बनता है कि क्या पता B इन्वर्स खुद का इन्वर्स हो जाए और C खुद का इन्वर्स हो जाए, तो केस हमने लिख लिया. दूसरा केस यहाँ क्या बनता है, केस नंबर 2, if B inverse is equal to C, C inverse is equal to B. Now this is cross. C inverse is equal to B, B inverse is equal to C. So this is the case. This implies that B inverse is equal to, pre-multiplying with B, we get E is equal to PC. Similarly, post-multiplying with B implies E is equal to CB. Therefore, BC is equal to CB is equal to E. Similarly, C inverse is equal to B implies BC is equal to CB is equal to E. Okay, this thing has been established. Now next is I am again writing G is the group A, B, C and आइडेंटिटी. तो अगर ये ग्रुप है तो इसमें कंपोजिशन जो क्लोजर प्रॉपर्टी हो सेटिस्फाई करेगी. ए बी जो है वो किसी इन्हीं में से किसी एक एलिमेंट, इन तीनों में से किसी एक एलिमेंट के बराबर होगा। बी सी जो है वो भी इनमें से किसी एक एलिमेंट के बराबर होगा। लेट अस वी फर्स्ट टेक ए बी। ए बी जी से बिलोंग करता है, देयरफॉर ए बी इज ईदर इक्वल टू बी और ए बी ईदर इक्वल टू सी, because AB cannot, because if AB is equal to A, this implies that B is equal to E, which is not possible. So AB जो होगा या तो वो B के बराबर होगा या AB किसके बराबर होगा, C के बराबर होगा. Now if AB is equal to B, post multiplying with B inverse, we get this thing. This implies that A is equal to E, which is also not possible. Which is also not possible. Therefore, AB is equal to C. Similarly, BA is also equal to C. Therefore, AB is equal to BA is equal to C. Now let us take A dot C. Since AC belong to G, this implies that either AC is equal to B or AC equal to C. If AC is equal to C, so post multiplying with inverse, this implies that A is equal to E, which is not possible because A is a different element from the identity. So you can write here which is not possible. Okay, therefore AC is equal to B. Similarly, we can show that CA is equal to B. This implies that AC is equal to B is equal to CA. Okay, so that thing we have determined. Now let me draw the composition table. This is E, this is A, B, C, this is E, A, B, C. E dot E is E, E dot A is A, E dot B is B, E dot C is C. A dot E is A dot A is E, because A inverse is equal to A. So pre-multiplying with A on both sides, A. This implies that A dot A is E, A dot A inverse is E, A square is equal to E. So this A square will be E. A dot B, you look here, A dot B is C. A dot C, A dot C is here B. So this will be B. अब आप यहाँ देखिए हर एक एलिमेंट डिफरेंट है, A, C, B, E हर एक एलिमेंट आया हुआ है इस रो में. यहाँ भी हर एक एलिमेंट डिफरेंट है. सिमिलरली B डॉट E इज B, B डॉट A इज C, B dot C dot C. So here is B dot C. What is B? Now let me see. B inverse was equal to C. This implies that pre-multiplying with BC, so E. So BC is E. BC is E. Okay. Now see, this is C. Now here you see this is the row and this matches with this column. This matches with this is A, this is A, E, this is C. So here should be C dot A. C dot A. You look here, C dot A is B. Is B. C dot B. C dot B. Where is C dot B? From here it could also be like we can also write here now. B inverse is equal to C. So post multiplying with B, we get CB is equal to E. So this will be CB. CB is E. So I'm going to write here as E. C dot C. Now look here, in this C has come, B has come, E has come, so only A left, so here I will be writing A. So this will give C dot C is C square is equal to A. And similarly here B in this row, B has come, C has come, E has come, so A will come. So B square is equal to A. Now we see in this composition table, we see that this row is equal to this column, this row is equal to this column, this row is equal to this column. So that corresponds to the property of abelian group, because if we see from the above composition table, we see that AB, A first, B is C, also if we see from this table, B, A is C. Similarly, we can see all composition AC, CA is equal to B, BC, CB is equal to E. So this way we can see that the elements are commuting with each other and satisfying the property of abelian group, because a group is said to be abelian group. When you said that a group is abelian group, if xy is equal to yx for all xy belonging to G, then we say that a group is abelian group. Therefore this is forming an abelian group. So this proves the theorem. So in this particular problem, we have discussed that if a group has 4 elements, then that group is abelian group. In this case, we have discussed the various different cases, case 1 and case 2 also. If you have liked the video, please like, subscribe, share and comment. Your valuable comment in the comment section are always welcomed and appreciated. This is all what I have from the video. So see you in the next video. Till then, stay at home, stay safe. This is Dr. Rajesh saying you goodbye. Thank you very much.